All right, everybody. Happy Pi Day. It is 3:14. Beautiful sunshine outside. I think spring has sprung, and I'm done with my platitudes. Okay, so this is kind of where we left off last week. This file has a bunch of stuff that's going on with my quantitative variables, age diagnosed, as well as sibling count. And in this graph last week, we were looking at different races and whether the number of siblings was markedly different to see if there was an association between these two variables. And really looking at this graph, not so much. I mean, a little bit this category seemed different than the others in that the max was so much lower and it's just a little bit less spread out, everything else. But more or less, there's not much of an association that we can see. As opposed to over here, when we did the age diagnosed broken up by gender, seemed like the girls were being diagnosed with asthma at a way older age on average than the males. You know, here the median is about 7, and here the median is up about 12. It's a little bit more spread out here, but overall, older girls getting diagnosed, younger boys getting diagnosed. So there's an association, at least it looks like there is, in this sample. Is it strong enough to think that there's an association in the population? Well, we haven't gotten to that part of the semester quite yet. We're building towards that, but we're not there quite yet. Okay, so moving to this week, what we're going to do is take our two quantitative variables and show a graph with one of those as the explanatory and one of those as the response. One of those is the input X variable, one of those is the output Y variable. So we're not going to use these categorical variables that I supplied you with. You're going to just put your two quantitative variables together. So we did an activity, or when I'm making this video, we haven't done it yet, but we're going to do an activity in class where you actually decide which of your two quantitative variables makes more sense to be the explanatory variable. You're putting what's called a causal model on your association idea here. And I'm thinking that when you're diagnosed with asthma, that's not affecting how many siblings you have. Your siblings are your siblings. But maybe the more siblings you have, the younger you get diagnosed with asthma, or maybe the older you get diagnosed with asthma, maybe there's something to do with this huge family and I don't have to, the kid's breathing hard again, whatever, just older sibling, go take care of your kid. They're breathing hard, as opposed to they're an only child and they're just going in at a young age and making sure they figure out what's wrong with their kid. I don't know. That's what I would speculate, is that maybe it's their number of siblings, the sibling count, that might be causing the age that they get diagnosed, thinking that the more siblings you have, maybe the younger your diagnosis, the older your diagnosis age would be. I don't know, making this up, but that's what I might expect. And so I'm going to put the sibling count as my X variable and the age diagnosed as my Y variable, with that model in my mind that might be what would happen. The name of a plot where you do a quantitative variable as the input explanatory variable and also a quantitative variable as the output response variable, that's called a scatterplot. And all it is a bunch of ordered pairs, like from algebra, because all these X values are a bunch of numbers and all these Y values are a bunch of numbers, and each person has however many siblings they have and what age they were diagnosed with asthma. So each line in the data set has a value for each of these two numbers. I'm just going to plot on a regular graph those ordered pairs. So for example, this person right here has 10 siblings and they were diagnosed with asthma, it looks like at age 1, for example. And this person over here maybe has only one sibling and they were diagnosed with asthma when they were about 31 or 32. That's it. That's what these dots mean. If there's an association and it's what's called a linear association, then you're expecting these dots to line up a little bit. Like, for example, if what I sort of suspected, that the more siblings you have, the older you are diagnosed with asthma, because they don't have time to take you to the doctor, when you were younger. They had too many kids running around. I don't know, making that up, right? Then you would see these dots kind of line up as I go forward. That the more I'm over here on the right, the more I'm up here towards the top. But if I'm way over here on the right, I got some stuff that's up here and some stuff that's down here. And if I'm over here on the left, I got some dots that are up here and some dots that are down here. And if I'm in the middle, I got some dots that are up here and some dots that are down here. I don't see any pattern at all, linear or otherwise. I don't see like a parabola or an exponential or a linear. I don't see anything. I see a blob of dots. So you would say, nope, no association here. But as you can see, this first line here, let's see if I can get the cursor off it. This first line here with the hashtag in it, this is just my note to myself. It's a comment. So Python's going to ignore that. And so my two commands are do a scatterplot, which is going to be using Seaborn, SNS, regplot, give it the X variable, the Y variable, fit reg equals false. If I make this equals true, all it's going to do is do the best it can to fit a linear regression line in there. And so, sure, that's the line that is the closest to all the dots on average. But I don't think that's showing us anything. It's kind of like meh. So I'm going to put that back to false. If your dots lined up, it would be nice to know in what line was the best model for that lining up dots, right? So anyway, I'm putting mine as false because the line's not helping me with anything. And then tell it what the data is. The data is all coming from DF. And then this title, so that up here it says, does the number of siblings seem to explain the age of asthma diagnosis? Okay, that's it. See you in class. Bye.